In this part of the chapter, we shall learn how to sketch the graphs of exponential functions. The equation of the graph of exponential function will look like this. Y equals to ka to the power of x. Unlike other power function, x is now the power. Now it is important to note that a must be positive and a cannot be 1. Let's look at a few examples of how an exponential graph will look like. The first example, we will have y equals to 2 to the power of x. Now, we shall start with plotting this graph here. The first point that we will use will be x equals to 0, and we will substitute in the value of x here. As you know, anything to the power of 0 will be equals to 1. And we will have our first coordinates here. We shall now substitute in a negative value such as negative 3. And we have y equals to 0.125. Finally, we are substituting in a positive value such as 3. And we have y equals to 8. Can you guess how the curve will look like? Well, the curves look like this. And it is important to note that the curve does not touch the x-axis. So, how do we sketch this graph? To sketch this graph, we need to have 3 values. When x is 0, we will have y equals to 1. And when the value of x is negative, the value of y will be very small. And when the value of x is positive, the value of y will be very big. And hence, we can sketch the curve in this way. Do note that the exponential curve will always be above the x-axis. Let's look at another example, y equals to 2 to the power of negative x. We shall first start with plotting this curve here. When x is equals to 0, our value of y will still be equals to 1. And hence we will have this point here. Next, when we sub in a negative value such as negative 3, y is now 8 instead. And when x equals to positive 3, we have y equals to 0.125. And likewise, we can plot the graph in this way. Again, the curve does not touch the x-axis. It is always approaching the x-axis, but it will never touch it. So how do we sketch this curve? To help us remember how to sketch, we will first sub in x equals to 0 to give us these coordinates here, 0, 1. And then, when the value of x is negative, well, the value of y will be big. When the value of x is positive, well, this time around, the value of y will be small. And that is how we remember the shape of the curve. Similarly to the previous graph, any exponential graph will always be above the x-axis. Let's look at a third example here. Can you guess how this curve will look like? Recall that the equation of an exponential function will look like this. So, how would this curve look like? Yes, since a must be positive, and in this case a is negative, therefore such a curve does not exist. Finally, let's look at the last example here, y equals to e to the power of x. How will this curve look like? Just like any exponential curve, it will look like the previous examples. In this case, it will also cut the y-axis at 1. Now you may ask, what then is this value of e here? To answer that question, let us first learn how to press e to the power of x. For example, e to the power of 1. To do that, we shall first press the second function followed by this to get e to the power of x. After that, we will press 1 so that we will have e to the power of 1. By pressing equal, we will have the answer e to the power of 1 equals to 2.718281828 and so on. And therefore, this is the value of e, and this is how we press e to the power of x. In summary, can you identify which curves belongs to the following equations? Now, it is very important to remember the general shape of the curves so that when you're either plotting or sketching, it will be easier for you. Do remember to copy down all the shapes of this curve and their respective equations into your notes. Well, that's all for this part of the chapter.